In this example, we're given a heat equation in that at time t, we can figure out how hot, what the temperature is, to be more specific, in degrees Fahrenheit, a cup of coffee is t minutes after being in a 70-degree room. Again, degrees Fahrenheit. So, this is a multi-part problem. Part A, we're looking at find what h prime of t is and explain in words what this means. So this is just kind of reviewing some of the information we've talked about throughout the whole semester and tying it together with integrals. And so h prime of t, we have to use the chain rule on this. So it would be 110 times the derivative of the outside would be itself, and then the derivative inside excuse me, would be negative 0.1672, and then we have e to the 1672t, and then the derivative of the 70 would go away. And then I could simplify this, but I won't right now. Excuse me. And what this means is this is the rate, if we were to figure out what this means, if I plug in 5 minutes, that's the rate at which the temperature is changing in degrees per minute. So h prime of t gives us the rate the temperature is changing of the coffee. I'm not writing all that down. We're talking about degrees Fahrenheit per minute. Remembering what the units should be on these integrals and derivatives can help you figure out what the meaning is of in words of what these functions represent. Part B, what would h of 0 be? Well, we plug in h equaling 0. If we'd get e to the 0 here and times 110. So I'll write this down, 110 e to the 0 plus 70. E to the 0 is 1. And you get 180 degrees Fahrenheit. What does it represent? It represents the temperature of the coffee at the time it entered the room, which sometimes Starbucks is known to brew it at 180 degrees Fahrenheit. Part C. What does this represent? And let's find its value. Well, like we talked about before, this is a rate of change of temperature. So the integral gives us the net change of temperature. So this would give us the change in temperature from 2 to 4 minutes. Say it another way, maybe the paraphrase, this would be the amount of temperature change from the 2nd to 4th minutes in the room. And then to find its value, we use the fundamental theorem of calculus that this is, since we're taking the integral of the derivative, fundamental theorem of calculus gives us its capital H of 4 minus capital H of 2. All right, so when we plug things in very carefully into a calculator, plugging it into here, we get that this is, when we round it, it's about negative 22.3789. So what does this mean? It means that between the 2nd and 4th minute, the temperature decreased by about a little over 22 degrees Fahrenheit. Part D, we are asked how much does the temperature change in the first 5 minutes in the room? So we're actually asked to find what is the integral of h prime of t from 0 to 5. Well, with fundamental theorem of calculus, it tells us it's h of 5 minus h of 0, which makes sense because if you just want to know how much it's changed, well, you subtract off what it started off with, and that will tell you how much it's changed by. And so again, this is what we might come up with on our own, especially if we're already given this. But sometimes this is what we know. We know h prime, but we don't know h. And so we have to take the integral in order to actually calculate this. And calculating this very carefully, we get about negative 62.3215 if we round to 4 decimal places. So that means in the first 5 minutes, the temperature has changed by a little over 62 degrees Fahrenheit. And according to the internet, best coffee should be at between 120 and 140. So after 5 minutes, it's too cold.